Welcome to Section 10, Lesson 6. Rational exponents bridge the radical notation from earlier lessons with the exponent rules from Section 2. Once you see how they relate, every problem with a fractional power becomes a familiar algebra problem in disguise. The definition is simple. A raised to m over n equals the nth root of a raised to the mth power. Equivalently, take the mth power first and then the nth root. Both orders give the same answer for positive a. The exponent rules from Section 2 carry over unchanged. Multiplying powers adds exponents, dividing subtracts, raising a power to a power multiplies. The exponents just happen to be fractions now. Negative rational exponents work the same as negative integer exponents. Take the reciprocal of the positive exponent form. So a to the negative m over n equals 1 over a to the m over n. The general rule. A raised to m over n equals the nth root of a raised to the mth power, which also equals the nth root of a all raised to m. Either grouping is correct, so pick the easier one for the numbers in front of you. Quick example. 8 to the 1/3 equals the cube root of 8, which equals 2. The numerator 1 means the first power, so we are not raising the result to anything more. Bigger example. 8 to the 2/3 equals the cube root of 8, then squared. Cube root of 8 is 2, 2 squared is 4. Always take the root first when the radicand makes the root come out clean. The negative case, a to the negative m over n equals 1 over a to the m over n. Flip first to handle the minus sign, then evaluate the positive rational exponent the usual way. Example 1, evaluate 27 to the 2/3. The denominator 3 says cube root, the numerator 2 says square the result. Take the cube root of 27 first. 27 equals 3 cubed, so the cube root is exactly 3. The expression is now 3 squared. Square it. 3 squared is 9. The number line confirms the location of 9, well past where 27 would sit, but matching the expression we computed. The answer is 9. Always do the root first when the radicand is a perfect power. The work stays in small integers and the final exponent step is trivial. Example 2. Evaluate 16 to the negative 3/4. The minus sign on the exponent means we will flip first. Flip. 16 to the negative 3/4 equals 1 over 16 to the 3/4. Now compute the positive rational exponent. The fourth root of 16 is 2, since 2 to the 4th equals 16. Then 2 cubed is 8. The denominator is 8, so the fraction is 1 over 8. The answer is 1/8. The number line confirms 1 over 16 to the negative 3/4 sits at 1 over 8, around 0.125. 3 steps flip for the negative sign, take the root for the denominator, then raise to the numerator's power. 3 takeaways for rational exponents. They make every fractional exponent problem mechanical. The definition. A to the m over n equals the nth root of a all raised to the mth power. Either order root first or power first produces the same result for positive a. Pick the order that makes the arithmetic cleanest. Strategy: take the root first whenever the radicand is a perfect nth power. The intermediate result is a small integer, and raising it to the small power m is trivial. Power first works algebraically but produces large intermediate numbers. Negative rational exponent, take the reciprocal first, then evaluate the positive rational exponent the usual way. The minus sign on the exponent always means a flip, never confuse it with a sign on the base.